Stangibelisco here, proprietor and operator of amateur radio station W1GV, Whiskey 1 Good Vibrations. A bit ago I showed you how you can inductively load a quarter wavelength vertical antenna to make it shorter, or rather, shorter, not as high, not as tall as a physical quarter wavelength would be in free space. You generally insert an inductor somewhere near the center of that radiating element, right around there. Well, you can also adjust an antenna to resonance by making it a little longer or taller than a physical quarter wavelength, and then employing a loading capacitor of the proper value to bring that thing to resonance. Now, it has to be an exact electrical quarter wavelength long in order to have resonance by itself. But when you do that, the problem is that the impedance is only going to turn out to be about 37 ohms. So what you want to do, if you want a perfect match, is make that thing a little bit taller than a physical quarter wavelength, and then resonate it to an electrical quarter wavelength. If it's a little taller than a physical quarter wavelength, roughly 35% of a wavelength tall, it will have a radiation resistance of 50 ohms. Unfortunately, that 50 ohms of radiation resistance will also contain reactance at the feed point unless you tune that reactance out with this loading capacitor. Choosing the right value for this capacitor will result in resonance and a perfect match to 50 ohm coaxial line. As things stand, a plain old quarter wavelength vertical has a radiation resistance of only about 37 ohms. And that does not provide a perfect match, although for all intents and purposes that improper match of only about 1.4 to 1 does not produce problems with losses, so you can tolerate it perfectly well, and most transmitters will tolerate that perfectly well. So that's not really the issue. The issue that we want here is to raise that current loop for this antenna somewhat above the feed point. Normally, for a perfectly resonant quarter wavelength antenna or an inductively loaded antenna, the largest amount of RF current occurs right at the base when you have a ground-mounted vertical antenna. But with an antenna like this, which is a little bit taller, the maximum RF current moves up just a wee bit, maybe a couple of tenths of a wavelength above the level of the Earth, and that will improve your low-angle radiation and probably also improve your antenna efficiency slightly, although you must always make certain to have plenty of ground radials in your antenna if you're going to mount a quarter wavelength antenna of any kind right on the ground. I use that technique on my own home antenna for 14 megahertz. It's actually 22 feet high, 22 feet tall, and I use a 50 picofarad capacitor right there, and I get a perfect match and also elevate that current loop slightly above the ground. getting the best of all worlds as far as that antenna goes. There are still better vertical antenna designs, in my opinion, than this. And maybe I'll make a video about that pretty soon. It involves a resonant circuit where this capacitor would be, and then a half wavelength physical radiator here. But that works according to an entirely different principle than this. This capacitive loading tactic can be used to advantage in amateur radio operations, and I use it. It works great. Stan Gibilisco signing off from somewhere in outer space, if I can get the arrow to allow me to kill this drawing so you can see it. Save changes? No. Then you got all this garbage, and then you can see the exploding star in all its glory. Stan Gibilisco, Whiskey 1, Good Vibration, saying 73, which means best regards in ham radio jargon, and so long for now.